Hello everyone, this is Professor Kuehn. A lot of you had problems on exercise 22.1, so I'm going to walk you through how to carry out exercise 22.1, which is on force, addition, and Newton's second law. It's important that you understand how to be able to add forces using parallelogram technique or another technique. So here's the idea, is that if you have a force in this direction, we'll call this force M, and M has a strength of 5 newtons. And there's another force that's acting on an object, and we'll call this force N, and N has a strength of 3 newtons. And you are told that the angle between these two forces, theta, is 60 degrees. So we have an object right here, I'll call this little m, that's the mass, and those two forces are acting on it, and we're going to find out how that mass responds to those two forces. Newton provides us with a technique for finding the net force. So first of all, what is the net force acting on the object? There are several ways to do this. The way that Newton explains is you draw a parallelogram, and then the diagonal right here is the net force acting on that object. Okay, and so how do we find what that net force is? There are several techniques. For those of you who came to my office hours, I explained one technique. Here I'm going to use a slightly different technique. Let's use the law of cosines. You might remember this from your mathematics classes. Use the law of cosines, and that is, I'm going to write some letters here. So this is point A, this here in the diagram is point B, this in the diagram is point C, and this in the diagram is point D. So the law of cosines states that the line segment AD squared is equal to the line segment AB squared plus the line segment BD squared. That kind of looks like the Pythagorean theorem, AB squared plus BD squared is AD squared. But since this is not a right triangle, there's a correction to this. So minus 2 line segment AB times line segment BD times the cosine of the angle between them. And the angle between them is our theta. Okay? No, I take that back. It's not theta. It is this angle up here, which let's call that angle alpha, cosine of alpha. Okay, now notice that since this angle right here, we'll call this angle right here angle gamma, and we'll call this angle right here, we'll call that angle beta. I know that's kind of small, but it's angle beta. Since angles gamma plus beta and angle alpha are supplementary angles, we know that alpha is 120 degrees. Okay, and then solving for the line segment AD, that's the diagonal, the net force, gives that the net force is 7 newtons. So that is the answer to the first part of the problem. We're basically finding the length of the diagonal if this is 5 and this is 3. A number of you made mistakes. You just said 5 plus 3 is 8. That's not entirely true. Well, that's not true at all. You can't just add 5 in this direction and 3 in that direction and get 8 in that direction. You have to consider the angles also. Okay, now using the law of sines, namely that sine of 120 degrees over 7 is equal to the sine of beta over 3 is equal to the sine of gamma over 5. We can find that the angle beta is equal to about 22 degrees. So that right there, so this force is directed at an angle of 22 degrees below the horizontal. So 22 degrees below the horizontal. Okay, so that is how that's one way to find out the magnitude of the net force acting on this and the direction that it's acting. Okay, let me pause for just a moment. Okay, so since the mass is a 1 kilogram mass, the next thing we're asked is to figure out the acceleration and the speed and the distance that it moves after a given amount of time. So we know that the mass was 1 kilogram, and we're asking how that mass responds to these forces. So using Newton's second law, the force acting on it, that's the net force, is equal to its mass times acceleration. That means that the acceleration that it feels is our 7 Newton force divided by 1 kilogram would be 7, and if you work out the units, it's 7 meters per second squared. So that is the acceleration that it feels. So notice that because the force is, each of these forces M and N are constant, that means the net force acting on it is constant. And if the net force acting on it is constant and its mass is constant, the acceleration is constant. So for constant acceleration, we know that the speed it has is equal to acceleration times time. That is from Galileo. We learned that back in the section on Galileo, and that implies that the velocity after 2 seconds is going to be 7 meters per second squared times 2 seconds is going to be 14 meters per second. So that's the speed that it is going to have after 2 seconds of this force acting on it. And it will be a velocity in the direction of that force. Now, how far does it move? Well, we can use distance equals 1/2 at squared. And again, we can use this because the acceleration is constant. So the distance it moves is going to be 1/2 of 7 meters per second squared times the time, which is 2 seconds squared. 2 squared is 4, times 7 is 28, divided by 2 is 14. So it will have moved 14 meters in the direction along this force. Okay, so now what's the next thing we have to do? We're asked what happens if it was initially moving leftward at 5 meters per second. So if the initial velocity, the original velocity in the x direction is -5 meters per second, so that's the way it was moving, then what would happen is we're asked what's the final speed and so on of this object. So to find this, we're going to have to be a little bit more careful. We're going to have to find out, we're going to have to separate this into both horizontal and vertical motions. So let's figure out the horizontal velocity. So the velocity in the horizontal direction is going to be the initial velocity in the x direction. I guess I'm using x for horizontal, plus the horizontal acceleration times time. And the initial speed in the x direction was -5 meters per second. And the horizontal acceleration, well, we know the total acceleration was 7 meters per second squared. So to figure out the horizontal component of the acceleration, we use 7 meters per second squared times cosine of our 22 degrees. So using trigonometry, this beta was 22 degrees, so 7 times cosine of 22. That would be the horizontal acceleration, and then the time would be 2 seconds. And so we can find the horizontal speed after 2 seconds is going to be 8 meters per second. And likewise, we can find the vertical speed, which is going to be the original vertical velocity, I'll call it the y direction, plus the acceleration in the vertical direction times time, which would be, well, we know the original the original vertical speed is 0, and the original, the acceleration in the vertical direction is 7 meters per second squared, and we can use sine of 22 degrees now. We're using trigonometry, and we multiply that by 2 seconds, and when we do that, we will get -5.2 meters per second. And so now we can find the total velocity is just the square root that we use the Pythagorean theorem, horizontal velocity squared plus vertical velocity squared. And let me go ahead and do this calculation. And okay, so that gives us, if we plug in our numbers, we get 9.5 meters per second. So that's the vertical component of the velocity is -5.2 meters per second. The horizontal component is 8 meters per second, and the total velocity is 9.5 meters per second. Okay, I'm going to squeeze in up here. If we want to know the direction that it's moving at that moment in time is going to be, well, we know it's moving at 8 in this direction, and it's moving at 5.2 in this direction. And so the this is what we just did, is 9.5 meters per second. We could figure out this angle right here. We could say theta, this angle right here is, let me just call this something different. I'll call this phi, is arctangent of, so tangent is opposite over adjacent, so 5.2 over 8. And let me do this calculation. Okay, and when I do that calculation, I will get 33 degrees. So that is the direction that is moving after 2 seconds if it had an initial speed of -5 meters per second in the horizontal direction. And I will stop